So that's part one. Part two is modelling. So to shift gear, again, I have to reset my brain to talk to you about computational modelling, because I will say I'm not an expert in this. The group that has been leading this for us has been a group led by my colleague Jason Thompson at the University of Melbourne. I would say I'm an amateur with enough knowledge to be dangerous of computational modelling, and I've picked a bit up along the way. So I'm going to try to describe this to you in relatively simple terms, but if you have really challenging technical questions, I'll have to get one of my colleagues from Melbourne Uni to answer them. Really what we were aiming to do here was to create a virtual model of an Australian workers' compensation system and then to validate and test that model. So the status of this is we've actually created two different types of models. We've created what's called a system dynamics model. We've established that, and it's currently undergoing validation, and I'll talk you through that process in a minute. And we've created what's called an agent-based model. It's set up and it's being prepared for the validation. So we actually have two computational models of workers' comp systems, and they're different in important ways, which is something that I'll talk a bit about. Before I do that, I just want to talk about why we're doing this. So historically, we've thought about things like workers' compensation system as a social system. You could think of a healthcare system or an employment system or a legal system as being a social system. Historically, we've considered these things to be complicated but predictable, where the sort of relationships between different people and different parts of the system can be understood almost in a linear way. But over the last decade or so, maybe a bit longer, we've really come to understand these as complex social systems, where those interactions are complex, they're dynamic, they adapt and change over time, and they're non-linear. And that's certainly what we see in workers' compensation. If you have experience in a workers' comp system, you know, the interactions between individuals in those systems change consistently and constantly. We see feedback loops, we see unpredictable outcomes. And our conventional methods of modelling, which are sort of epidemiological methods or other sorts of similar mathematical methods, what I've sort of generally put into reductive methods here, they're not very good at predicting outcomes in these systems because they don't take into account much of that complexity. And we just need alternative methods. And over the last decade or so, there's been this real explosion in computational social science, which is creating models of social systems that reflect this sort of complexity. And that's what we're doing in the Workers' Voice project. So you might be asking yourself, what the heck is a computational systems model? Well, it's really just a virtual or a digital representation of a real-world system, and that is developed based on real-world data, and where we don't have access to real-world data, expert input. And it contains the features of a real system, but it is not a real system. So a nice analogy that one of my colleagues uses from Melbourne University is it's like a Lego set. Like this is the Lego hospital on this slide. And you can see it's got all the components of a hospital, has wards, has a medevac helicopter, has ambulances, has doctors, has patients, has an X-ray machine, all those sorts of things. And through these sort of virtual systems, we can measure the processes that occur within the system, the outputs and the outcomes of the system as well. And we can use these virtual systems, importantly, and this is what we want to do in this project, to test changes to policies and settings and processes and the impact of those without having to put them into play in the real world. So there's no harm in testing all sorts of weird and wonderful things once we've established a validated computational systems model. I will say there's lots of different types of computational systems models. We have focused on two for this project. There's what's called a system dynamics model, and the other one's called an agent-based model. And there are some differences between these. So the system dynamics model is very good at representing the groups of people and their movement or pathway through a system. So it's easiest to sort of think of this as stocks and flows, as injured workers with certain characteristics might go through one part of a system. Say that might be an injured worker with a very complex or serious injury in a workers' compensation system might get different sorts of benefits and services to an injured worker with a relatively straightforward physical injury. And you can sort of imagine how that might operate in a sort of virtual system. An agent-based model really more focuses on individuals, or what we call agents, hence the name. and the interactions between those individuals. So in this case, it might be injured workers, case managers, doctors, employers. And we define the characteristics of each of those agents, and then we measure the relationships between those and the outcomes they produce for injured workers, in this case for injured workers and for others as well. It's a bit harder to get your head around that, so I'll show you an example in a second. There are a few steps in building a computational model that we've been going through. The first one is to describe the system that you want to replicate, and we did this through writing it down. So we've got this document that is sort of the foundational basis of these computational models, where we actually said, here's how a workers' compensation system works from the point of injury until the point of exit from the system, whether that be return to work or retirement or a lump sum being paid or something else. And that was actually quite challenging to say, because we have multiple different sorts of systems in Australia, to say, here's the step-by-step process that we tend to go through in workers' compensation. And we had to write what the rules were, write who the actors or the agents were, what the processes were, what outcomes we thought they produced, and look at the relationships between the different people or agents in those systems and write those down. So we've got this explicitly written now. And then we start creating the virtual version of that based on that description, and we find and incorporate data to help us represent the very many different parts of the system. And sometimes that's hard data. So for instance, we've lent quite heavily on all the analysis that we've been doing of the national data set of workers' comp statistics and the National Return to Work Survey and other analysis that we've been doing to inform our model. And sometimes it's soft data, and we have asked quite a few experts. Mary, I think, was one of the experts that we asked about specific aspects of how systems function, but other people who have a long history of operating in these systems as well. We've sought their opinions to make sure we're getting this right. And then we build it on a computer, we test it, we refine it, we test it, we refine it, we go through this iterative process until it's producing sensible outcomes. And the way we know it's producing sensible outcomes is we try to go through this validation process where we compare what we're seeing in this virtual model to real life examples. So we might say, one of the things we're hoping to test here is the legislative reform that occurred in New South Wales in 2012. We've published a couple of academic papers on the actual outcomes of that reform in terms of claims volumes and duration of time lost in these schemes, so we know what actually happened. We can go through and try to replicate that in our virtual workers' compensation system, and if we sort of see the same or very similar outcomes, we know we've got a system that's operating like a virtual system that's operating like a real workers' compensation system did. And that's the stage that we're at the moment. We're at the validation process of building these models. Before I show you the big models, I'll show you some little ones just to sort of explain what they are. So the system dynamics model is really thinking about stocks and flows. So we have a number of people coming into a system or a part of a system that might be 10,000 injured workers a year coming into a workers' compensation system in some part of Australia. They form the stock, and then certain things occur, and every year a certain number of those return to work or leave the system, and there's an outflow. And you can think about that at a micro level as well. It might be the number of workers coming in to see an independent medical examiner, and then the outflow from that. So we can have stocks and flows represented in lots of different parts of the system. And then we have variables which might influence things like the outflow. How many people actually leave the system? That might be influenced by the policies in place within that system and whether or not a scheme is able to pay redemptions, or the duration of time for which income benefits are available, all those. So you can imagine all sorts of number of variables which might influence that sort of outflow. And then we sort of build these other more complex things, and we gradually build these sort of system dynamics models up and up until you end up with really what is a very complex set of interactions. And all of these decisions about the relationships and things are based on data and understanding how the systems work. In an agent-based model, what we're doing is actually looking at the interaction between people and different types of people. So here the sort of ovoid people called agents here might be injured workers, and the sort of squarish one might be a lawyer or a return to work coordinator in a workplace, all of whom might have relationships, where the injured worker might have a relationship with this other agent. The blue ovoid things might be workers with mental health condition claims. The green ones might be workers with occupational diseases. The black ones with injuries. The orange interactions might be negative interactions. The black ones might be neutral or positive interactions. And so you define the agents, the features of the agents, the type of agents, the interactions between them, and then you pop that into your computational model and you let it run in a sort of, in a virtual system, and you measure the outcomes of that. So that very quickly becomes computationally very complex because you're literally tracking thousands and thousands of interactions and outcomes and variables in a sort of real time. Here's what they look like when you scale them up. So this is our system dynamics model, or a version of it, a visual of it, of a workers' compensation system in Australia. So you can see all the different sort of little stocks and flows and feedback loops, and there's different pathways through the system. I've sort of labelled different components of it here so you can kind of understand what's happening. It starts from the point of injury and claim lodgement and ends with an exit from the scheme, which can occur in multiple different ways, not just return to work. And we go through some of the main steps or processes that we see in a workers' compensation claim. So eligibility determination, triage and screening, the early claims handling process, and then in some cases where claims proceed to longer term, we have a mid and longer term claims handling process, and eventually everyone in one way or another exits the scheme. And so we have built this based on all that data and understanding and knowledge of of how a workers' comp system operates, and that's what it looks like in a static form. The agent-based model we built, here's a visual of it, and the colourful bit in the middle is actually a visual of the model running, and you can sort of see little people represented there and other shapes. The little people are workers, the other shapes are other agents in the system, so they will be claims managers, which are the triangles. There'll be doctors, which are the stars. There'll be employers, which are the squares. There'll be independent medical examiners, which are the pentagons. And the colour denotes sort of the interactions between those people. Green being a positive interaction, red being a sort of hostile or a negative interaction, and yellow being neutral. On the left and under that, we've got all these variables, which are the settings that we can apply to these agents in our system. And the system itself. So we can look at, for instance, if you look at the third one down, it says the probability of GP support. So that's the likelihood that if you go and see a GP, they will support your claim. They will say your injury is work-related and I'm going to help you make a workers' compensation claim. So we can adjust that setting to test that as a policy impact. And on the little set of graphs are the sort of outcomes that we can track from this system. So things like the number of approved claims, the average mental health of the workers, the average claim duration, the number of service requests that are approved, client satisfaction, some time-based variables, all sorts of other things that we can model as well.